Say we want to mix two sounds together in a Bytebeat program. Mixing is just adding, so it's natural to assume that adding one sawtooth wave to another would give us a blend of the two sawtooth waves, but it doesn't. Let's look at one sawtooth wave, T, and another sawtooth wave that's twice as fast, T times 2. To add them together graphically, it's helpful to look at the points where one or both waves reaches a maximum or a minimum. Here, they both start at 0, so the sum of the two will also be 0. Here, the blue wave falls to 0, so our new green wave will be equal to the red one, but just before that, blue is at its maximum, so red plus blue will put our new green wave up here before it falls. Over here, red and blue are both at the maximum, so green will be twice that, and then they all fall to 0 and start over. Of course, you could always do the math. But this leaves us with a wave that goes over our maximum value of 255, because we're using an 8-bit output that can only count from 0 to 255. So, each time our new wave would exceed the maximum value, it's wrapped around to 0 and continues from there, making our wave look like this. Notice that now it's a normal sawtooth wave, just going 3 times as fast as the original. This is because our two terms aren't being wrapped into sawtooth waves until after we've added them together. If you think about it and remember your basic algebra, we could have known this from the start. See, t times 2 is the same as t plus t, and t plus t plus t is the same as t times 3. All we've done is change the slope of our ramp, which changes the frequency of our sawtooth wave. Now, it's not always true that adding two sounds makes one new sound that's just like the others but higher in pitch. That only happened because they were both sawtooth waves in our example. Here, we have a more irregular waveform, and we'll add it to a square wave. At the peaks of the square wave, the resulting sum just pushes the irregular wave up higher. And where our sum would exceed the maximum, it's wrapped around from 0. This gives us a completely new sound, not just a higher version of the original sounds we added together. So, how do we use addition to make a mix of two separate sounds? Well, remember that T is not really a sawtooth wave until it reaches the output. It's really a continuously climbing ramp that's wrapped around to 0 whenever it reaches the maximum output value. We want to do that wrapping ourselves before adding it to another sound. Now we've encapsulated this sawtooth wave so it will keep its shape and then can divide it by 2, which makes it quieter. This allows us to add another sound to it without the risk of wrapping around to 0, creating those new unexpected waveforms. We'll do the same with our other sound, t times 2. We'll apply a modulus of 256 to wrap it within the boundaries, then divide it by 2 so it leaves room to add our two sounds together. Now, with such a simple ratio between the two pitches, it's hard to hear them as distinct sounds. But listen as I change the multipliers. It changes the pitches of each one separately, so you can hear that we really do have two distinct sounds mixed together. Now we can add the two waves to make our new result, which should look familiar, except that this time it doesn't exceed the maximum value and wrap around to 0. This is how we cleanly mix two sounds together, so we hear them both. Now there are 3 lessons to be learned here. First, don't forget to use basic algebra to reduce your equations to their simplest forms, at least when you're trying to understand how something works. Second, if you want to cleanly mix multiple sounds together, apply a modulus of 256 to each term individually, then divide by the number of sounds you're mixing together. Or if you want some to be louder and some to be quieter in the mix, use different numbers as long as the average of all the divisors stays higher than the number of sounds in the mix. And finally, now that you know how to mix sounds cleanly and avoid artifacts from wrapping around, take time to explore the possibilities of making those artifacts happen on purpose.